Welcome to a session on when to reject and when not to reject the null. Before we get into the discussion of this, I do want to go over a couple of definitions, the definitions of the p-value and the significant level. So the p-value is the probability of getting the sample you got, or one that's more extreme, meaning a sample that's more extreme, assuming the null hypothesis is true. Now, normally, that is the technical definition, but I tend to just say p-value is the probability of getting the sample you got. So, in statistics, the p-value arises when you take the normal CDF and you find the area under the curve that corresponds to the probability of getting your sample. So, when you take normal CDF, and in general terms, you go from one z-score to another z-score, and your calculator gives you a decimal. That decimal is the p-value. This is the p-value. Okay, and of course you can, with your decimal, you can move the decimal point over 2 places to the right and get your percent in a percent form rather than decimal. But that's where your p-value comes from. The significant level is, I abbreviate it sig level. It's the level at which you reject the null hypothesis, H sub 0. In a little bit more general terms, it's the level at which you discard a notion or an idea. So I'm going to give an example. Suppose I write, here's my null. And this example I'm going to give you is not so mathy, it's a little bit more of a real-life situation, so you get an idea of what we mean by the significant level. Suppose I have the notion, or the idea, that I'm going to keep my 10-year-old car. Okay, so I'm going to keep my 10-year-old car, that's what I'm thinking is my null. And then a little while later, my car breaks down, and it costs me in repairs, let's say $250. And I think to myself, well, I guess I could still keep this car. It's an old car, but I don't think I could buy a new car or even a used car for $250, so I'm going to hold on to it. And then maybe 3 months later, breaks down again, and it costs me $175 in repairs. And I think to myself, well, I'm starting to question I'm going to keep my 10-year-old car, but I think, well, still I can't get that car for the same for $175. I might as well just spend it and invest in it, and so I'm going to keep my car. And let's say 2 months later, guess what? My car breaks down again. And this time it costs me, let's say, $350 in repairs. And now I kind of go, you know what? I am not going to keep my 10-year-old car. I am tired of this. Done. So in that case, I am rejecting or discarding my initial notion that I was going to keep my 10-year-old car. And that's the level that it took. It took basically spending that much money and this much time to make me change my mind. So, in statistics, though, when you're talking about the significant level in statistics is symbolized by the Greek letter alpha. Okay? And in statistics, you assume that the significant level is 5%, or 0.05 in decimal form, if not given. Now, obviously, if you are given, so if not given. If it is given, then use whatever was given. why can you have different significant levels? Well, in the same way about this car, the example about the car, you know, somebody might have given up right after the $250, or someone else might have kept going. Everybody has a slightly different idea of at what point do they discard that idea that they're holding on to, the null. Okay, so, but in general, at least we will use 5% unless otherwise mentioned. Now, I also want to mention here, I want to kind of get a sense of the big picture. So we've gone over the definitions. Oops. Sorry about that. All right, so I wanted to get an idea of what, give you an idea of what the big picture is, and then we'll go into more details. But the big picture is, suppose I have a null, and I'm going to leave this sort of general, because again, I don't want to get lost in the details. I want to keep it a big idea. Suppose the null is an idea that could be true. Now remember, could be true. We never know if it is true or not. And the alternative, let's say, is maybe the truth is greater than I thought. Okay, so there's an idea that could be true, it's what I think, but maybe what I think or the truth is actually greater than what I thought. So then what happens is you have an idea, so that's the center. That could be true. And you have a sampling distribution around that idea. The distribution of expected samples you would, think you would get if your idea were true. And then you would take a sample to see, well, is my idea plausible or not? So then when you take your sample, the idea is if your idea, which is the center of this distribution, is correct, if what you think is true is correct, then your sample should be sort of in this region right here, close by, close to what you think is true. So let's say you do get a sample that is close by, and say my sample is right here. Well, that sample is reasonably close. It's a very reasonable sample. And the probability of getting that sample, in this case I would shade to the right because the alternative says that the truth could be greater than what I thought. This area under the curve is the p-value. It is the probability of getting the sample I got if the null is true. And that is basically, this is a very reasonable sample to get. Why is it reasonable? Because it's very close to the center of the distribution. Now, it doesn't prove that the null is true. It just says the null could be true. But what we can say is that the alternative is not true. Since I got a sample that was very reasonable, it substantiates the possibility that my idea really could be true, and therefore the alternative would not be true. So if I get a very reasonable sample, then the alternative is not true. Now, on the other hand, suppose I think this is the idea that could be true, and instead, let's say I get a sample that's pretty far out, like way out here. Here's the sample I get. Well, that sample is very far out. It's what I would call an unreasonable sample. It's very far out. And then when you find the probability of getting that sample, again, you shade to the right, this is my p-value, the area under the curve. Well, it's a very small p-value. So it's basically saying that, well, why is there such a small chance of getting that sample? Why is my sample so far from what I thought could be true? It's because what I thought was true is not true. So that disproves the null. So in this case, I would reject the null and I would say that the alternative is true. So you would say the alternative is true. Okay, that's the big idea. Is your sample reasonable or is it unreasonable relative to your idea? All right, so in general, when you get your p-value, so this kind of ends the big picture, here's what's really going to happen. You're going to compare your p-value to the significant level, alpha. If the p-value is greater than the significant level, you're going to write, do not reject null, and then you're also going to write the conclusion, and you're going to say there is not enough evidence that the alternative, and you have to put that in context, is true. Whereas here, if the p-value is less than the significant level, you're going to write reject the null, and then you'll also write for your sentence, the conclusion, there is strong evidence that the alternative, again, you're going to write that in context, is true. Okay, so let's go to a more specific example then. Suppose I say, suppose I have a null and that's going to be percent is 25. So let's say that represents 25% of adults drink at least 8 ounces of water per day. So let's say that's something we're testing. And then the alternative is P is greater than 25%, so that would be more than 25% of adults drink at least 8 ounces of water per day. Alright, so then let's suppose you checked your conditions, everything's good, and you're now going to make your distribution of expected samples. So let's suppose you have a sample size of 80. Your standard deviation is going to be here. And we're going to round to about 0.05 for the, just to get a general idea of the distribution of expected samples. So here we go. Here's the center at 25%. That relates back to your null. And then we just got a standard deviation of 0.048, which I'll round to 5%. So we'll have 30%, 35, 40, and going this way to your left, 20, 15, and 10. All right. And let's suppose you get a sample that's 28%. So what that means is 28% of the adults in your sample drink at least 8 ounces of water per day. Now that sample falls right about here on your distribution. So that sample is very reasonable, and when you shade in the direction of the alternative, the P is greater than 25%, so you're going to shade to the right. When you go ahead and get your z-score, and you say, how far is my sample from the mean standardized? And you get, it's 0.625 standard deviations away. You calculate your normal CDF to find the area under the curve, which also represents the probability of getting the sample you got. And let's say you get here 27% for your p-value. Remember, what comes out of normal CDF is your p-value. So what that means is there is a 27% chance of getting a sample where 28% of adults in the sample drink at least 8 ounces of water per day. So that's a very high chance of getting that sample. So how we would follow through on that then formally, you'd say the p-value is greater than the significant level because 27% is greater than 5%. Remember, we assume the significant level is 5% unless otherwise stated. And because this was such a reasonable sample to get, it's close to the mean, which is at 25%. You would say, do not reject null. And then you would write, there is not enough evidence that more than 25% of adults, and that's all adults in the population, drink at least 8 ounces of water per day. Okay? Now that finishes this example. We're going to continue it and say, well, what if we had gotten a sample that was unreasonable? Let me just make a comment here that when you're first learning statistics, it's a little bit, there's a tendency to say, well, wait a second, my sample was greater than my mean, than my null, so my null is 25%, but 28% is greater than that, so shouldn't I just go ahead and accept the alternative right there? No. And the reason is, what you're saying is the sample I got, even though it is a little higher than 25%, 28 is higher than 25%, it's a very reasonable sample. It's close by. And because it is so close, it could be true that it could be that 25% is true. Because remember, when we take samples, there's a lot of sampling variability. You don't just go out, take a sample and always get 25, 25, 25. That's not going to happen. So because of the sampling variability, some of your samples are going to be a little bit lower and some of them are going to be a little bit higher. But if they're still very much close to the mean, then the mean could be true. And this is exactly what's happening. All right, let's go ahead and take this same example. And in this case, suppose we got a sample that was far from the mean. So in that case, suppose we had instead the same distribution where here's 25% and same sample size, pretty much same everything, but let's say instead we had gotten a sample that had 37% instead of 28%. In that case, when you do your z-score, you get 2.5 standard deviations away. Boy, that is really far away. So then you say, well, and by the way, sorry, here's your sample. It'll be right about here somewhere. That's pretty far from your mean. So you have a very small, that's your p-value. It's the area under the curve. And as you can see, here's your, this is your z-score. Here's coming up, what comes out of normal CDF is going to be 0.006, which is 0.6%. There's your p-value. So that's a very small p-value. You're going to end up rejecting the null. Let me go ahead and interpret this. This is saying that there is a 0.6% chance of getting a sample where 37% of adults in the sample drink at least 8 ounces of water per day. Well, obviously that's such a small chance of getting that sample. So that must mean that reality, which is my sample, is telling me that, oops, what I thought was true, that 25% of the people, adults, drink at least 8 ounces of water per day, that means that can't be true. So formally you would write p-value is less than the significant level, and that's because 0.6% is very much less than 5%. You would say reject the null, and then you would write there is strong evidence that more than 25% of adults drink at least 8 ounces of water per day. There you go. Thank you very much for listening.